Hello, this is the fourth lesson of Unit 1, and today we are going to doing a lot of like little details. So I'm going to discuss with you outliers. I'm going to go through a heavy kind of amount of vocabulary just to make sure that we're all on the same page in terms of communication. And we're going to go over standard deviation. Okay, so there's several things. You will need your calculator for the last part of the lesson. So outliers, I should have mentioned this. Outliers are things that are a little different from the norm. So that's why we have this picture with the red fish in it. So you can base your understanding of outliers kind of intuitively and just be like, oh, this data point or this particular element is an outlier because it doesn't fit the rest of the pattern. But there also is a rule of thumb, much like with the histogram, rule of thumb. There also is a rule of thumb for identifying outliers. So if you have some numerical data and you're like, is that particular value an outlier? How different does it need to be from the rest of the data to actually be called an outlier? That might be our question. Well, this is a rule of thumb that statisticians use to try to determine that. You put the data in order, small to big, or big to small, and then find the interquartile range. That is what IQR stands for. And so the word range on its own would mean the highest minus the lowest. The interquartile range means quartile 3 minus quartile 1. So it's equivalent to, on a box and whisker plot, figuring out how long the box part of the box and whisker plot is without the whiskers on it, okay? Then you're going to take the interquartile range, multiply it by 1.5. You'll add that to Q3, you'll subtract it from Q1, and those two new numbers are what we would call the fences. Anything that lies outside the fence is an outlier. So if I were reading all of that for the first time, I'd be like, okay, blah, 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 you sound like Charlie Brown teacher, wah, 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 right? You have to actually do it in order to understand it. So let's actually do an example. So here's a data set. This is in your packet or on your notes page, if you have that in front of you. And it's just some data that I pulled up from Winter Olympics one year, men's ski jumping event, and here are their different times. And so, or points, I'm not sure what this is. Okay, but it's a set of numbers we can use. So you can see that it is in order from the largest number to the smallest number. And in the box there, I've already done the 5-number summary. I did that on my calculator. So if you recall, it said that the first step was to put things in order. The second step was to find the IQR. So from my 5-number summary, I will find the IQR by taking the third quartile and subtracting the first quartile. So the distance between Q3 and Q1 in this case is 29.75. Then I'm going to take 1.5 times that result. 1.5 is just a fact of the rule, right? Rule of thumb. And I get this number, 44.625. Now, if you imagine like having a number line, I'm just going to use this space up here. Here's a number line. Q1 is here, Q3 is here. I'm going to be looking for a cutoff here and here. And so I need to add this number that I just got to Q3, and I need to subtract, right, because that's how number lines work, small to big. I need to subtract this number off of Q1, and that's going to tell me where these cutoffs or fences are. So I'm going to take the Q1 value, and I'm going to subtract the 44.625, and I'm going to take Q3, and I'm going to add 44.625. When I do that, the two values I get are 162.075 and 281.075. So those are what we would call the fences. So now I need to look, do I have any data that lies outside of that? So first the 162. These numbers are higher than that, so they are within bounds, but this number is lower. So like on my number line, this is like where 162.075 would be. and the data point for 111 would lie outside of this fenced in region. And then over here I have 281, and I want to know, do I have any data that is higher than that? And it turns out I do. I have this data point. Oh, that one makes it. That one would be inside of the fences. Okay, so I have two outliers, my small and my largest value. 3 dots like this means therefore. So therefore 111 and 283.6, my min and my max, are outliers. You can have as many outliers as you have. You might not have any outliers at all, okay? But that is the rule of thumb test for outliers. All right, so this slide has a lot of vocabulary on it. I am not going to write down every single thing because one of my hesitations in making video lessons is always worrying that there might be someone who just looks at the video and doesn't listen to the video. And so to encourage the listening on this part, I am not going to write down as much as maybe you should. So you will see that in your notes packet, I have these terms written out on the notes page that you can get on Schoology if you don't have a paper copy yet. And I've grouped them into little chunks. And so I'm going to talk through each chunk and then ask that you pause and think and make sure that you have everything as complete as possible. Okay, so the first box on the page has mean and median. These two are measures of center, meaning that they describe where the middle of a data set is. The mean is what we would typically call the average, although technically the median is also a type of average. This is where you take the sum of all the data and you divide by n, the number of numbers. So if you have 12 numbers in your data set, you're dividing by 12. The median is, I always think of as being like the median on a road. So when you're driving and you say, oh, don't go across the median while you're driving in driver's ed. The median is that center thing in the road that sometimes has trees or something on it. And so think about the median as being the center. And so this is the middle value. If you have an even number of numbers, like let's say that you had 6 numbers, then the middle is actually right here. It's in between 2 numbers. So what you do in that case to find the median is take the center 2 numbers and then you find the average or the mean. Okay, I would like you to pause now and make sure that you have written down everything that you want to write down. You could rewind and listen to what I said again to make sure your notes are as complete as you need them to be. All right, the next chunk in your notes has 3 terms: mode, outliers, and resistant. The mode is the most common value or values. So I like to remember that by noticing that both of these terms start with MO. So you can have a data set that has multiple modes. So let's say I have a data set that looks something like this. It's 1, 1, 2, 2, 3, 4, 5. Both 1 and 2 would be modes because they are tied for the most. If I had an additional 1, then my only mode would be 1 because it is literally the most common. If I have a data set where every number is just there one time, like this, 1, 2, 3, 4, 5, I don't have a mode at all. So if every number is there once uniquely, there is no mode. So you can have multiple modes, you can have no mode. An outlier is what we discussed earlier in this video, remember? Okay, that was about outliers. And being resistant means that you are not impacted by an outlier. So this is resistant to outliers is what the full phrase might be. And if you consider a set of numbers, like let's say you have 1, 2, 3, 4, 5, like I had a second ago. In this particular set of numbers, the average and the median are both 3. So in that set of numbers, the average is 3, the median is 3. If instead of having that 5, I had 40, the median is still 3. So even though I have an outlier, right, a very extreme value in this data set, that's very different. That 40 is very different from 1, 2, 3, 4. So even though I have an outlier, my median hasn't changed. And so the median is resistant to outliers. However, my average here would no longer be 3. My average is going to be changed a lot by having that 40. In fact, it would be 50 divided by 5, which is 10. So my average changed a lot because of having an outlier. So we say that the mean is not resistant to outliers, okay? The median is. That's important to understand. Okay, again, I would invite you to pause, rewind a little bit if you need to review these last few terms. Make sure your notes are complete. Okay, the next box that I want to go to is the one that contains range and IQR. I actually mentioned both of these earlier in today's video. Range is where you take the highest value and subtract the lowest value, or the maximum minus the minimum, whereas IQR is quartile 3 minus quartile 1. So the R here stands for range, both in regular range and in interquartile range. You are doing a subtraction problem because you're trying to judge how wide part of the data is. The range is the width, if you think of it visually, it's the width along the number line of your entire data set, whereas the IQR is the width of the box part of your box and whisker plot. Okay, again, pause, and if you need to, make sure your notes are complete. All right, these next few words, this is over on the left-hand column in on your notes page. These next 5 terms are kind of cool. They all describe the shape of a data set. So a symmetric data set would be like if your histogram overall has this sort of a shape, right? So there's something in the middle and it's the same on both sides. Whereas a uniform distribution is a histogram that looks more like this. Everything is the same. So I drew a curve up here, but what I was like picturing is having like a histogram that looks kind of like this. And I just drew sort of the overall shape, whereas a uniform distribution, you're drawing more like a horizontal line. Now, you don't have to have it be perfectly like either of those shapes in order to use these vocab terms. This is like symmetric-ish, uniform-ish, right? Like just kind of the general shape, okay? Unimodal, uni means one, and modal refers to the word mode. So unimodal means one most common thing. So that would be any shape that has one very tall peak. Okay, so say I had my histogram shape looking like that. Okay, there is one tall peak, one tallest bump. Okay, bimodal is where you have 2 tallest peaks. So maybe your overall shape is something like that. Okay, so like a 1-humped camel and a 2-humped camel. Skewed is something that folks get confused, and I totally understand why. I'm right there with you, because it does seem like it's defined the wrong way. So a skewed distribution is where you have your bump off to the side. This first example that I drew in orange pen is actually called being skewed right, because skew is named for the direction of the tail. This is skewed left, because the tail is long on the left side. Okay, so you look for the direction of the tail in order to name the direction of skew. The last 2 terms are gap and cluster. This is exactly what it sounds like. So if you have a gap in the data, that's where you have a hole or something that's missing. A cluster of data is a lot of data that's really, really close together. So let's say that I had like a really good student and they were listing out all of their test scores. I might say, wow, look at all that. That's really quite the cluster, because they're all like really, really close together. And maybe they have a gap and then there was one score that was kind of lower and different. That might be an outlier, but there's certainly a gap between 70 and 88, right? But the rest of the data is clustered together. Okay, so these don't really have like fancy definitions. It's more like intuitive, right? A gap is a whole, a cluster is when all the numbers are close together. So what I'd like you to do next is to pause, and I'd like you to put a circle around any term on this list that is a measure of center. I'd like you to put an X by any term that is a measure of spread, and put a smiley face by any term that is a description of a shape. Okay, so please pause the video and then come back once you've labeled. Okay, we could debate a few of these, but this is what I did. So I said to circle the ones that were measures of center. That would be your mean and your median. X's by the measures of spread. That's range and IQR. And then all of the terms that are on the right-hand side of my screen, those are all measures of shape. These two, if you did not call these last two measures of shape, that's okay. Really though, these are definitely measures of shape or ways to describe shape. Now, thinking about range and IQR, we said those are measures of spread. Another measure of spread is something called standard deviation. And I know that before I started teaching stats, one of the main places I remembered seeing this was on standardized test reports. So you might have seen that like on your ACT report or something like that, or your MAP test from when you were in middle school. So I'm going to teach you how to do this by hand as well as by calculator. All right, so first of all, I want us to change the example a little bit. This example was not the best the way that I had it initially written, so if your notes don't have this correction, please make sure that you fix it. Okay, so let's say that we are looking at a student named Monica. Monica's taking college algebra, and the teacher gives quizzes on homework, and Monica's scores are kind of all over the place. She's earned anywhere from a 2 to a 17 on her quizzes. So the first thing that we're going to do to calculate standard deviation by hand is to find the mean or the average. So you can do that obviously just by adding these together yourself. And then since there are 7 quizzes, we would divide by 7. And then that gives us an average of 8. Okay, so her average is 8 points. To continue on with finding the standard deviation by hand, I recommend that you make a table or a chart like this. It just is a good organizer so you don't lose track of what to do. Put the data set, the original numbers, in the first column. And then in the middle column, you write down how far each of these values is from the mean. So it's each individual data point minus X bar, which indicates the average. X with a line on top is red, X bar, that means average. So 2 minus 8, for example, is -6. In other words, when she scored 2, that was 6 below her mean. Okay, so I'd like you to finish that middle column and come back when you're done with that. Okay, so that's what your middle column should look like. A nice way to check your arithmetic here would be to add these up, because this column should always total 0. Okay, so that's a way to just check that your arithmetic didn't mess up somewhere. Okay, the next column is squared differences. So you're going to take the differences in the previous column and take them to the second power. So for instance, -6 times -6 is +36. And you go down the column and square each of those. Okay, then the rest of the process is to find the sum of this column. So you're going to add those up. You're going to divide by 1 fewer than how many numbers you have. So we have 7 values, right? There were 7 quizzes. The letter N is typically used for how many, like how many numbers you have, so N for number. So I have 7 values. I'm going to divide by 6. If I had 12 numbers, I'd be dividing by 11. It's always 1 less. And then I take the square root of that result. So add these together, put that in here, divide by 6, take the square root. Please pause until you have that calculation done and then come back. Okay, so this is what I got. My total when I added together the squared differences was 168. I divided that by 6, and then I took the square root of that result. Okay, so hopefully you got the same answer. Let's take a look at how that works on the calculator. So there are two different kinds of standard deviation that are located on our calculator. One uses the Greek letter sigma, and that is going to be a symbol that we will later use for standard deviation, for example, when we are studying the normal distribution, the normal curve or the bell curve. For now, we are going to be looking at the sample standard deviation. And there's deviation. I can write, oh my goodness. Sometimes writing and deviation. I was on this part in my head. Sorry. So sample standard deviation. The word sample is something that we're going to be discussing a lot in Unit 3 to explain like why I'm calling it sample. So for now, I guess really all I need you to know is that this is the symbol for standard deviation and that this also means standard deviation, but not the kind that we're dealing with right now. Okay, just tuck that away in your mind so it doesn't perplex you later. So on my calculator, on your calculator, you should take a second and put in the data set that we're talking about. This is Monica's quiz scores. Then once you have that, go into statistics again, over to calculate, and into one variable statistics. Now we have been here before. This is where you find the 5-number summary. But the part that we're interested in is up here. So we scrolled down previously. But right now we can see that right up here at the top, there's our mean or our average. It's another way to find the average. It's just right there in one variable statistics. And right here, this S with the little x, that's our sample standard deviation. This is that other kind of standard deviation that I mentioned. That's not what we're doing right now. Okay, but the sample standard deviation is what we're talking about. So that's easy enough to find on your calculator, certainly. Okay, at this point, you should be all set to do the individual homework, which is problem set 1.4. Thanks.